All right. So thanks for joining today. I'm here to talk to you about the next generation of Scala. So first, a little about me. My name is Adam. As mentioned, I'm a core contributor to Zio, so maybe a little bit biased there, but I will try to disclose that at least. I first learned Scala from Martin Odersky's Coursera course, like some of you may have. And I remember from the beginning, I always loved the beauty and the elegance of the language. I felt like it let me say what I wanted to say and not have to say anything more, but just say what needs to be said. And I also got a lot out of the type system, as I find whenever I try to do something in Python or a language that is just not strongly typed, I have many runtime errors, and then I'm very glad that I have the Scala compiler. So I'm a big Scala fan. And normally I talk about particular features in Zio, but I thought for this talk I would step back a little bit and try to share at least my perspective on where Scala has been in the past and where it's going. And I think this is a really good time for that because I think the future for Scala is really bright right now, with both Scala 3 coming out and really doubling down on some of the things that make Scala Scala, as well as some of the libraries that are coming out right now that are really just helping solve practical problems in a very powerful way, hopefully Zio being included in that. But at the same time, I think we've had periods in the past where we also felt like the future was very bright, and maybe sometimes that hasn't been fully realized of. I think even if we look at the name of this conference of Scale by the Bay, it used to be Scala by the Bay, and it's great to have more friends and more languages and look at things together. But I think that partly reflects the fact that Scala maybe didn't grow as quickly as people thought it would to support this conference just being Scala. And I think you can see that in other ways where I imagine many of you may have used Scala in the past and may not be using it today. So I want to spend some time looking at where we've been and where we're going, and hopefully encourage you, if you're not working with Scala today, that there's never been a better time to come back. So with that, where have we been? Well, I think to answer that, we've got to start with the language of Scala and what makes Scala special. And there's this quote from Martin Odersky from one of the talks on Scala 3 that he did that I thought summed things up very well. And he says that the essence of Scala is a fusion of functional and object-oriented programming in a typed setting. So he's saying there are these two different things. There's functional programming, there's object-oriented programming, and Scala is going to let us get a fusion of them. So that sounds great, right? We get the best of both worlds. We can use these very high-level functional abstractions when we want to, and when we want to, we can manipulate arrays, and we can use each of those tools when we want to for the problem. So sounds really good. What's the problem? Well, the problem is that choice creates uncertainty. That if you just tell me like, hey, I want black coffee, okay, I can get you black coffee. But if you say, well, I want some coffee, I want some milk, does that mean I want coffee with a splash of milk, or does that mean I want latte as a milk with a splash of coffee? And we've got to kind of figure out where we want to be on that spectrum between object-oriented and functional programming. So we can be more object-oriented, which we might call a better Java. We might be very far on that functional programming side of what you could call a poor man's Haskell. Hopefully what we want to be is what you call distinctly Scala, that sweet spot in the middle where we're taking the best parts of both of them and putting them together in the right way. But where exactly on that continuum is that sweet spot, and what does that look like? Not everyone agrees on that. And that creates challenges for teams, because if you're an organization, you can probably be productive with any of those styles, but you probably need to be consistently using one of those styles. And first thing you have to do is you have to decide where you want to be, which can be particularly challenging if you're a new organization adopting Scala, because you don't necessarily know what you don't know of what the trade-offs are of where you want to be on this continuum between object-oriented and functional. Then you need to onboard new team members, and you need to get them on board with the style of Scala that you want to use in your team, which can be challenging because they may have their own style of Scala that they're more comfortable with or they want to use. And you've got to maintain consistency there, which can be challenging. I think a pretty common thing I see is people have someone come on board who really wants to do things a certain way. They do part of the code base that way, and then they move on for whatever reason. And you're you're stuck maintaining that. And then the other thing as a user is you got to decide which libraries you want to use, because you may have some situations where there's a certain library that is the best point solution for this part of your stack. But if it has a very different style than what you're trying to do, if it's very functional and you're trying to just do better Java right now, or it's very imperative and you're trying to be super functional, neither of those are going to be great for you. And the same challenge exists for library authors. So as a library author, you might say, well, what style should I write my library in? And at one level, the answer could be whatever you want. You're the library author. If you're taking your time to do it however is interesting for you. But you might say, okay, well, that's great, but I want to do it the best way for my users. What is that? And it may not be entirely clear. And then you also have this issue of how do you integrate with other libraries? Because just like users have this problem, you're going to have an issue that if you're taking one style, you may have a challenge integrating with libraries that pursue a very different style. And all of this creates risk that as a programming community, as either a company or as a group of open source developers, you have to decide where you want to fall on the spectrum, and there's risks to being too far in either direction. So if you're too far in this better Java direction, you can make things that are really useful, but there may not be a reason for people to do them in Scala versus in another language. On the other hand, you can go very far in this functional poor man's Haskell direction, and you can create some things that are really, really interesting, but that are maybe not that useful for at least the average programmer. And hopefully what we're doing is we're getting to that distinctly Scala sweet spot where you're developing something where people in other languages are saying, boy, I need to use Scala just to get this software. But finding the right place to land there is challenging. So let's take a look at a couple of examples of this. So I think Akka is a great example of something that falls on that better Java end of the spectrum. It's very useful. So it takes this actor model that was very useful in languages like Erlang for some very complex challenges or things like telecommunications, and it brings it to JVM. These actors encapsulate mutable state, so they let you work with mutable state in a concurrent environment in an otherwise imperative framework that's probably more similar to what you're used to, in a way that lets you manage that state better. And actors are also really interesting because you can think of an actor as a microcosm of a node in a distributed network. And so if you build some system with a set of actors that are communicating, that naturally scales up from concurrent processes on one machine to a distributed system in a way that may be less obvious with other frameworks. So really useful there, which is why it's had the success it's had. On the other hand, at some level, you could say you didn't really need to do it in Scala. The fundamental signature of an actor is a partial function from any to unit, right? It says, hey, send me some message. It can be any message at all. I'll pattern match on it and decide what to do with it. And then I'm going to do some kind of side effect based on it. Don't know what it is. Now, that's completely untyped, so you clearly don't need to use Scala's type system to do that. Since then, now there's Akka typed. There are more types here, but the fact that Akka probably was most predominant in a period when it didn't have types indicates people weren't going to Akka because they wanted types. People were going to Akka for all the reasons that we talked about on the previous slide. And so the implication of that is that over time, now you don't need to use Akka in Scala, you can use it on Java, and that community has kind of grown away from Scala a little bit, which makes sense because there are lots more Java developers. And if you don't actually need Scala, then it makes sense to broaden out to this wider market. Another example of this would be Spark. So Spark's incredibly useful, great software, solves a variety of problems in distributed computing of if you're working with data and data flows in a distributed setting, it solves a lot of problems for you. This collection analogy that Spark promoted, where you get to think about these distributed data sets largely as collections and work with them with operations on Scala collections, is extremely powerful, and I think a really good example of abstracting over complexity for users. And it's probably the most impactful Scala project in history. So there's a lot of credit to go there. At the same time, it's another one where there's not necessarily a reason to do it in Scala. And that's why lots of people don't do it in Scala, and they do it in things like Python with PySpark. And so now when I talk to data scientists, they're like, why would I do it in Scala? I do it in Python. And so Scala in a way is great for Spark contributors of they get to use the Scala language and its features to be more productive. And I think particularly in the early days of Spark, there was more of a differentiation between Java and Scala there. So that's wonderful. But the fact that to really use it, you generally don't need Scala has led to people not doing it in Scala. And so there was at one point this idea that Spark was going to lead to Scala becoming the lingua franca of data science. And that never really happened, which, yeah, again, it's great that the software exists and it was developed in Scala, but maybe if we're big Scala fans, we might say, well, it's a shame that it didn't end up bringing more people to Scala and getting more development just in Scala itself. So that's one extreme. The other side we can be on is the going very functional, or what you call the poor man's Haskell side. And I think you could think of Scalaz or Cats as going in a little bit of that direction. And so on the one hand, they brought some really interesting ideas into the Scala ecosystem. So these underlying concepts have some deep beauty to them, at least to me. And I remember the first time I learned about monoids and foldables, and I saw how many collection operators you could implement in terms of them, and then how that could generalize to more probabilistic structures like Bloom filters and Sketch, and how you could aggregate these across distributed systems. Like there's a deep beauty and structure there that I thought was really cool. In addition to that, these were the first libraries, particularly like Scalaz, was the first time you could really do functional programming in the large in Scala. Before that, the sweet spot was definitely you would use functional programming for your collections, but then when you wanted to interface with the network, you would go on and you would do it imperatively. And this was the first tools that let you program in the large in imperative context, or functional context. So a lot of really interesting ideas that they brought to the Scala ecosystem. At the same time, there are some aspects of this approach that I think make it less useful, at least to a broader group of developers. And I think maybe the first thing is just the goal a little bit, I think, of these libraries was to let you do functional programming in Scala, which is great, but in a way, that's a problem you have if you're a functional programming fan and you've just got to work in Scala because that's the job you've got. That's not a problem that organizations have, right? Companies have problems like, I need to build this distributed system, or I need to ensure a very high degree of correctness in this thing that I'm building. And functional programming can be a great means to accomplish those ends, but it's a means, it's not an end. And these libraries could often have very high barriers to entry, where like I've included above the signature of an HTTP route from one of these libraries. And so it's this Kleisli of an option T, of an F of a question mark, of a request and a response. And this whole thing is actually not even valid Scala 2 syntax. You need to add a third-party compiler plugin to make this compile, because the actual signature of this would be too ugly for me to show you on this screen. And if you've kind of read a book on functional programming, then this makes sense. If you haven't read the book, then you're going to have a bad time, and you have no idea what this like Kleisli or option T thing is, or why this question mark is here, and what this F is. And so it just creates this like barrier to entry, where if you're in this like small group of people who like doing functional programming in the style, it's like fantastic for you, like this is the tool for you. But if you're kind of an everyday person who's like, hey, I just want to like deploy my like server, this is like, okay, now you've like added a whole bunch of other stuff I need to do before I can actually just deploy my server. And it can also often just lead to a poor developer experience, because even once you overcome that barrier, there's just often additional boilerplate there of kind of like, even here, you've got like these 3 layers of nesting and going through them and using these different operators to do it, where it's not as easy as it could be. And I think one thing that kind of jumps out here is this like Kleisli thing of, you might wonder like, what is this Kleisli thing? And it turns out it's not what is Kleisli, but who is Kleisli. So he's a mathematician, he's a category theorist. There's a thing called a Kleisli category that's associated with him. So the name is kind of to pay homage to him, I guess, which is nice, is a very nice thought. And if you are someone who's coming from that category theory background, it's probably going to be very clear what this thing is to you. But the flip side of that is that no one else is going to have any idea what this thing is. And admittedly, there's already some complexity of like what this is. I mean, it basically adds the ability to have context to some other monad, which represents some kind of effect. But you could try to pick a word that would like convey that in some way. You could call it contextual, or sometimes reader T or something. But this is like, no, we're going to really focus on like this one group of people, and we're going to make sure it's very clear to them, but it's really not going to help anyone else as far as naming. And I think this gets a little bit to one of the challenges that I think we have to like catch ourselves on as people who really do love functional programming, is what I call the learning fallacy, which is this idea that, well, like they should just learn about it. Like if that like Kleisli of option T thing of look complex, then you should just learn about monads and monad transformers. And once you learn about those things, your life is going to be wonderful. And in a way, that's coming from a good place, but there's a problem there that it essentially assumes that other people don't have other things that they're doing. It's a great thought of saying like, oh, you should learn about category theory. But the reality is you probably already had a full plate. You were trying to solve your original problem. Maybe you're trying to learn about other things. Maybe you're trying to learn about machine learning. Maybe you're trying to learn about distributed computing. Maybe you want to actually get some exercise in. Maybe you want to spend some time with your family or your friends. So when someone says, well, you got to learn about category theory now, which of those things are you going to drop because you're supposed to learn about category theory? So I think at this point, we've had the better Java of useful, but maybe not a reason to do it in Scala. We've had the very, very functional of kind of a poor man's Haskell of bringing some really interesting ideas in, but maybe not in a way that's accessible to the broader group of developers. So where are we going from here? And I think the answer is that the next generation of Scala is libraries that focus on being distinctly Scala. And those are going to be libraries that play to Scala's unique strengths. So libraries that leverage Scala's type system, which is probably the most powerful of any mainstream language, to create type-safe DSLs. Libraries that take on complexity so users don't have to. And libraries that are relentlessly focused on developer productivity, because the real differentiator for Scala is letting teams of developers be very productive. So again, from my biased perspective, I think one library that is an example of this is Zio, which is a framework for building cloud native applications in Scala that lets you declaratively describe parallelism and concurrency and gives you powerful guarantees around resource safety and the ability to see how and even whether your application can fail at all. So here's an example of what a snippet of code written with Zio would look like. And so here we're calling Zio.for each par. So we're saying for each of these files in parallel, we want to do something. And then we're saying for each of those files, we're using this acquire release with constructor, which is the concurrent version of try finally. So this is going to open this file. And when we're done with it, it's going to guarantee that we're going to close the file. And while the file's open, we're going to process it. And it's going to do this whole thing with a level of parallelism of 8. So we're only ever going to have 8 files open at a time. And as soon as we get done with one, we'll open another. And then we'll time out this whole thing after 60 seconds. And so just this pretty terse bit of code does a lot for us. So we're processing these files in parallel. We're making sure we never have more than 8 files open at a time. We're stopping on the first error. And as soon as the first error occurs, we're going to automatically interrupt all of the other files we're working with. And we're going to make sure that those files are still safely closed no matter what. And then we're going to time out the whole thing after 60 seconds. And if we pass that timeout, we're going to shut down the whole thing, and we're still going to make sure all these files are closed. So we're getting these very powerful guarantees and really describing a lot of logic at a very high level. And I think this is, at least from my perspective, very much reminiscent of what got me attracted to Scala in the first place. Each of these lines here says exactly what it's doing. And I think about as close to plain English as you could for code. And there's nothing else here. There's no F, there's no implicits. There's just a concrete data type that we're doing these operations on that are describing what we want to do. And in addition to being useful, Zio uniquely leverages Scala's type system. So the core data type in Zio is this Zio REA, which represents a workflow where R is the dependencies of our application. So this might be, we need a logging service or we need a database. And E represents how our application can fail. And A represents the success type of our application. And because of Scala's support for variance, which is a feature that Scala actually has that, for example, Haskell does not have, because Haskell doesn't have subtyping, doesn't have variance, these dependencies and error types naturally compose. And we'll see what that means in a second. And so this is something that you can't get in Haskell, you can't get in Java. You need Scala for this. And so here's an example of what that composition looks like with the error type, where here we have this domain error type of a password error, and it's got 2 subtypes of an IO error or an invalid password error. And then we've got these 2 different workflows. So this first one's going to get some user input, and it can fail with an IO error. And the second one's going to validate that input, and it can fail with an invalid password error. And if we put those together, if we get the input and then we validate it, we're automatically going to get an error type of password error that is the combination of these 2 error types here. And that's using Scala's support for variance to do that. And you see the same thing here with the environment type, where here we've got this method here that requires some kind of Bloomberg service to get some stock prices. We've got this method that requires a logging service to do some logging. And when we write a workflow that does both of these things, we naturally get an inferred type that requires both of those dependencies. So again, using Scala's type system. In addition to that, Zio actually does have this deep algebraic structure. So we can take those ideas that we got from those very functional, very kind of Haskell libraries, and we still have all those properties here. So Zio is a monad and an arrow and an index monad, and actually has an even richer structure that can be described by those because they don't have the ability to describe these three different type parameters and how they interact with each other. There are also powerful laws about interruption resource safety and how those relate to each other. And we get all this without any higher kind of types or type classes. So we don't have to kind of have that just to have that structure. We can have the structure and have a very concrete, accessible representation. And there's also a growing ecosystem around that. So libraries for configuration, HTTP server, serialization, persistence, stream processing, and lots more. And there's even a lot of functionality like logging metrics that are actually built into Zio in Zio 2.0. So all this is leading to more and more companies adopting Zio. And some of these companies were using Scala, now using Zio. Some of these companies weren't using Scala before, now using Scala with Zio. None of this is specific to Zio. Those same principles can be used by other libraries. So I think a great example of that is Calihan, which is a GraphQL library that follows a similar philosophy of purely functional on the inside, but that's not what they're about. What they're about is making it very easy for you to derive and validate a GraphQL client and server based on your data model. You just define essentially just a hierarchy of your sealed traits and case class, describe your data, it'll generate it for you. And it's massive time savings when you use this. And this is the type of thing that if you're a company and you're looking to deploy a service that's based on GraphQL, you might say like, hey, I need to use Scala. I want to use Scala because I want to be able to take advantage of this library. And that's ultimately where we need to go. Of course, there's nothing magical about this. You can do this with your own library. So I think the key ideas here are being both deeply principled and deeply pragmatic, using functional programming as a tool, as a means rather than an end, and letting users focus on solving their problem. So you solve your concerns so they can focus on solving their problem. They don't have to just kind of learn the internals of what you're doing. And if they want to, they can at their pace, but they don't have to. So in conclusion, I think there's never been a better time to come back to Scala. There are more and more libraries being developed focused on solving real world problems in a very ergonomic way. And libraries to make you want to use Scala. And you can be a part of helping to build this next generation of Scala. So actually, later today, we're going to be having this year's Zio Hackathon. So I'll post a link to that on the Discord after we get done with the Q&A. But I'd really encourage you to check that out. There's going to be a great talk introducing Zio. If you haven't worked with it before, then talks introducing a bunch of Zio libraries, and we're going to be hacking together over the next couple of days. So really fun opportunity if you're interested in looking involved. But hope you found this talk helpful, and wanted to thank the conference organizers for their time. Eric here for his introduction, Alex, Ale, Anastasia, as well. I know there were a lot of other people involved who I did interact with. Want to thank all the other Zio contributors, all of the Zio users. Feedback from our users is incredible and continuing to improve what we're doing. John DeGoes in particular for being a mentor to me personally. And then finally, I'd like to thank all of you for taking time out of your day to attend today and listen to this. Hope you enjoy the rest of the conference, and thank you so much.